Over at they have started to think about starter kits and various different things, how to accelerate their org, how do they share common patterns across. And if you've ever interacted with GitLab, you've probably remember the whole include 1 billion things and it all gets super nested and crazy environment variable clobbering, and you can't tell what's going on, what's going to be done, and it's like difficult to version, etc. Right? Problem. And at the end of the day, it's all one gigantic merged YAML file. Well, GitLab in our working with and GitLab, they've actually come out with a new thing called CI/CD components. At the end of the day, it's still one merged YAML. We're going to get to that, but it is at least a framework that is better structured to building shared reusable workflows. Ironically, it becomes more similar to how GitHub does like GitHub Actions and GitHub shared workflows. It's really like moving towards what GitHub does, but it's still one merged YAML. The way this looks like is this, right? So we have a component section within our Liatrio 2 org. A component will look like this, very much more action-like versus just a bunch of my GitLab CI YAML file with a bunch of names and all that stuff. All right. And the cool thing is you can actually run actions against your components. So you'll have like a templates folder, and those templates will include your new components. The one beautiful thing about this is no more clobbering of global environment variables. It is now actually like dedicated inputs, very similar to GitHub Actions. The other really cool thing that they did here is they created this thing called a CI/CD catalog. So because this is now a CI/CD component, it's almost like a developer portal in a way, where if you want to see what components your org has for various different CI/CD aspects, you can come here. And so you can see here we have a couple. We have General Util version 004 and Maven. And you can see exactly like what the components are, how to import them, what inputs they accept, etc., and even what they call. That's a nice little usage thing for people wanting to like jump in and get started and like say, I want to go build a Maven app. Okay, but at the end of the day, it's great to have this view. It's great to know what you can import at what version. But at the end of the day, it's still one merged YAML file. So detecting usage is still a problem. Understanding as a platform team who is using it, how many versions are in use, etc. That's still a problem. GitLab does not have a solution for you. The event stream that comes out of GitLab provides none of this information because, again, it is one merged YAML at the end. How did we fix that? So first off, before I get to how we fix that, let me show a demo project that imports these components, right? This is a demo project that imports 4 different components at varying different versions, okay? And they run the various different stages in there to lint, test, build, release the application. Great. What we did was build a processor that will inject the information into the event stream as it comes through. So conceptually, this is what an OTel collector does, right? It has various different receiving mechanisms. It has various different extensions and processors that will make telemetry more meaningful for you, and then it will export it into your backend. So in a couple of days, I whipped up a processor for GitLab specifically. So what we do is GitLab will emit its events for pipelines over into the webhook event stream receiver and the OpenTelemetry collector. We run some transformations that change the telemetry that's in there. Then we drop what we don't want. Then we change it again to make sure that the changes match a semantic convention in the OpenTelemetry space. And then we send it to the GitLab processor, which then forwards it to the exporter and forwards it to OpenObserve. Okay, what does the GitLab processor do? The GitLab processor basically looks at each log because an event is a log. So it looks at each log that comes through it. And the fun fact is this could be the same done for the traces as well. So you could actually just make this a trace processor. But for each log, if it matches a set of semantic conventions and has a specific set of data for those semantic conventions, then we're going to reach out to GitLab, parse the GitLab CI YAML at that specific revision or hash. And then if the components exist, we're going to add attributes to that event and ship it out to the next pipeline. What does that look like in practice? So I've got here one of those logs. What I did was I just triggered a pipeline and I have all this being sent locally. So there's like a whole other side of my terminal, like, you know, using Tailscale funnel to get things from the external internet to my local machine, running the collector. And what happens is those events come in and they go through some parsing and some transformation, as I mentioned. And what comes out on the other side is attributes of component dot component name dot version, and then the value is the version. All of those logs come through, and that enables me to build a dashboard that simply tells you like version numbers that have been used in the last 15 minutes for various different pipelines. So these are the various different versions that have been used in the past 15 minutes. Actually, it's a little longer because the screen is cached. I'd have to go back an hour because I seeded the data about an hour ago. But it tells you what the different things are, right? And so you could, I whipped this dashboard up in about 5 minutes. It was a very quick dashboard. I clicked a couple buttons and it was there. Very easy to do because you have semantics in place. You could scale this out, right? You could do this based off of traces. You could even change like, okay, which ones are throwing errors? And you could start to make decisions that are data-driven based off of telemetry within your system. But this is just a very quick like usage of versions across the board and what components are being used. If I were to, we'll go back, let's see, go back here. If I were to just go ahead and trigger a new pipeline, let's make a change. I didn't prepare for this, but let's do it. I'm going to bump these to .4 because there is a new version 4. Ooh, where's my keyboard? We're just going to ship it to main, you know, trunk-based development. Being what it is. Hopefully those versions exist. I'm pretty sure I made them exist. Wow, that was quick. I wish you could have seen the other screen. I'm going to swap over to the other screen, the terminal, real quick. So in here, in this tab, you can see I just got like some like logging output, right, for the processor. But the event got sent to my collector, and I immediately detected that these were the components that showed up. Okay, so you can see now that like the components, they match the GitLab CI file that we had, you know, up over, and it processed it and it sent it over to our OpenObserve backend. So if I go back here, we should see that dashboard update. If I do the last hour, okay, so maybe I seeded a little longer than an hour ago. We'll go 3. All right, so these are the versions that have been in use over the last 3 hours, right? Now we've got version 4 for these two, but of course these two are still at version 2. So like, you know, this scales is the thing about it. I don't have to inject any type of script inside of my pipeline that makes it more fragile because it can't hit a data backend or any of that stuff, right? I'm simply listening outside of any of the pipelines and able to get this telemetry, make it meaningful, and build out the metrics from it. The cool thing is also on the metric side, like, you know, there's a whole cardinality thing. They're not actually being sent as native metrics. They're being sent as log events. So you can perform all sorts of different analyses against them. But I also did this like to show them the art of what was possible. I also showed them the tracing solution. So if y'all went to KubeCon, there was a talk there by some folks in Germany. It was a CNCF ambassador and then someone who works at Clario. They built a GitLab receiver. Surprise, they built a GitLab receiver. We have a GitLab receiver too. Ours does primarily metrics right now. Theirs did traces. And they demoed it on stage. And to show like what could be done, I simply ran this too locally, rebuilt our collector with their GitLab receiver. And I was immediately able to get traces based off of what happened. Now, of course, I don't have the semantics in here for those attributes, but it would be very easy for me to change the processor to say, hey, instead of where we've got logs, but let's also turn it into a traces processor. And so for each action span that comes through, we can just look at it and attach a specific event to that, a log event to the span. And then we could see this information in our traces, which allows you to do all sorts of additional things too. And it keeps it a nice, good braid of telemetry. That is what we end up wanting. One side note, just real quick on semantics, the semantic conventions that like we look for are things like what is the repository name and the repository head revision. That's what we're looking for in the underlying code. If they have that, because I have some assumptions that I built based off of this like 2-day proof of concept, then I'm able to go make the call to GitLab, do some processing, and it's done. And it's a very quick and effective mechanism to do this. And then the last thing that I'll show is like, what am I running locally? I'm running this new kit on the block called OpenObserve. They are an open core company, meaning that you can self-host this. And what I love about this is it's one, not Grafana. So there's not 3 different backends for telemetry. It is literally, you can store all of your telemetry in S3. And so for a long-term storage of things, which I generally don't recommend, but sometimes it is a hard requirement by the business. This is a good value add to a company who wants to store all their stuff in cold and warm storage and like an S3 bucket, or if they want to use, like if they're in Azure and they don't want to use S3 and AWS, they can use Minio, which is S3 compatible, and they can search all their telemetry for forever, right? And it's very, very cheap, but it's also super context rich. So you don't have like these super amounts of cardinality problems because it's all just blob stores. So I don't recommend self-hosting observability platforms generally. I usually the default is go buy a SaaS like Honeycomb that is doing observability 2.0, that essentially their backend is a columnar store. They're not doing 3 different data stores. But in the event that you want to self-host things, this actually might be one of the really good alternatives for you to run. In fact, we're going to bring this into KPV3 to host some of our Dora and our data that we don't want to send to Honeycomb. So be on the lookout for that. That's it. I just wanted to show getting telemetry out of a system that doesn't have telemetry or anything meaningful out of the box, and you can fix it, right? So that's it. Any questions?